Okay, so today we spoke about several things, but I'm going to just talk now about the photoelectric effect. So the photoelectric effect was a phenomenon that was noticed in that if you have a zinc or a metal plate, for example zinc, and it has a negative charge on it, then shining light of a particular frequency f, as long as f was above a certain value, electrons could escape from that surface. Okay? If f dropped below that value, no electrons could escape. Increasing f, so if f is too low, no electrons. As you increase f, the electrons can escape. The rate at which the electrons could escape did not depend on f though. Once you reach that value of f to allow the electrons to escape, increasing f further does not make more electrons escape. But what then was noticed was, however, once f is above that threshold frequency to allow the electrons to escape, if at that stage you increase the intensity of the light, then more electrons will escape. So the more intense the light, the more electrons could escape. But when the frequency was not above that certain threshold, when the frequency was below that threshold, no matter how intense the light was made, no electrons could escape. So kind of two important facts. One, nothing happens unless the frequency of the light is above a certain level, no matter what you do to the intensity. And two, once that frequency of light is above a certain level, then increasing the frequency further has little or no effect on the amount of electrons that escape, but at that stage, increasing the intensity does. Okay, so this puzzled scientists for a while until Einstein came up with a theory. And Einstein's theory was pretty revolutionary. Basically, what he said was, instead of light being thought of as a wave, think of light as a particle or a stream of particles. And these particles are like bundles of energy. They're called photons. So these photons have an amount of energy in them. And the amount of energy that a photon contains is a constant called Planck's constant, which is in your log tables, times the frequency of the light. So the energy of each photon is h times the frequency of the light. And what happens is, in Einstein's view, is the photons can pass their energy to one electron only. So the photon passes its energy to an electron, and if the energy of the photon is enough for the electron to escape, there will be a minimum energy requirement needed by the electron to allow it to escape from the surface. That's called the work function of the metal. And the work function is the amount of energy that the electron needs. So it's the energy the electron needs to just escape from the metal. So as long as the energy of the photon is enough when it passes it to the electron to be equal to the work function, then the electron can escape. If it's too low, if F is too low, the electron can't escape. So all of these photons may be trying to give their energy to the electron and may give it, but it's not enough energy for the electrons to leave the surface. However, if you raise the frequency of the light until it's above this value, a certain value f, then hf, when hf is equal to or greater than the work function, now the electrons can escape. Okay, and that was Einstein's proposal. He also stated that only one photon could give its energy to one electron. So there's no point in having loads and loads of photons, because if F is too low, you can't combine all your photons together and give them to one electron. You have to, one photon, one electron. And the electron will not escape unless that individual photon has enough energy in it to be equal to or greater than the work function energy that it needs to escape. And then the only other piece that we mentioned today was if the energy of the photon is a certain value, okay, so if it's a certain value and that value is greater than the work function, the photon will still give all its energy to the electron. The electron will use that much energy to escape, and any excess energy that the electron has is kinetic energy. So it's a half mv squared. So in other words, the energy of the photon minus the work function will be equal to the excess energy that the electron has, and that is seen as a half mv squared. And that's known as Einstein's photoelectric equation. Okay, so calculations for homework should involve that. So to be aware again, that's the work function, that's the energy the minimum energy that an electron needs to escape. This is the energy of the actual light that is going to shine on the metal. If this, of one of the photons of the light that's going to shine, so it's the energy of each photon. If the energy of the photon is greater than the work function, any excess energy is given off as kinetic energy of the electron. So the electron has kinetic energy when it escapes. The other thing is this work function, you could also, if you know what the threshold frequency, if you know what value of F causes the electron to just be able to escape, then that is known as the threshold frequency. So the threshold frequency is the minimum frequency that the light needs to have in order to allow the electron to escape. So in other words, Planck's constant times that threshold frequency provides you with the exact energy the electron needs to escape. In other words, it's the work function. Okay? So hopefully that will be enough for you to do the homework tonight.